Hello, my name is Alex Thomason. I will be doing problem 84, unit 5.1, and it is worth 5 points. The question is to locate any relative extrema and to find the inflection points, and to use a calculator to confirm your results. The equation is y equals x minus ln of x. So, our first derivative will be y prime equals 1 minus 1 over x, and 1 over x is the derivative of ln of x. And to find the relative extrema, we need to set y prime equal to 0, or where it does not exist. So y prime 0 equals 1 minus x, 1 minus 1 over x. So 1 equals 1 over x. So x is equal to 1. And that is a possible relative extrema. And we do the first derivative test to find out if it's a maximum or minimum. So when x is less than 1, y is less than 0. So that is decreasing. And when x is greater than 1, y prime, we need a prime there, y prime is greater than 0. So that's increasing. So we have a minimum. And then our other relative extrema is when y prime does not exist, and that is at x equals 0. And so that's when y prime does not exist. So we have a vertical asymptote. So x equals 0, x equals 1, and a minimum. Alright, so that concludes our relative extrema. Our inflection points my marker's not good, so I'm going to switch markers. Our inflection points is when, our second derivative, which is y double prime, which equals 1 over x squared, and we derived that from y prime equaling 1 minus x to the minus 1. And so inflection points are when y double prime is equal to 0 or it does not exist. And we can see here that y double prime cannot equal 0, so cannot equal 0, and does not exist when x equals 0. But that's not in the domain of x. Or f of x. So it's no inflection. Non-inflection point. Alright. When we were finding the relative extrema, I forgot to put the y prime right here. It asks us to confirm our results with a calculator, and we can see on this calculator that when x equals 1, that is our minimum, and nowhere on this graph does the does the concavity change from maximum to minimum? So we know there are no inflection points.